Hello, humans! Welcome to part 2, polar coordinates. So we are moving on. There are some similarities to this and the vectors, and I'll show you when we get there. But let's get started. So polar coordinates are a different way to plot points or to graph equations. We are going to be comparing it to rectangular coordinates, which we write as x, y. We know how to graph those, right? If it's the coordinate 2, 5, we would go right 2, and then we would go up 5, and then this would be our point right here. Of course we know that. But now I'm going to change everything that you know about graphing, and I'm going to say that we can graph on a different type of graph, right? We can graph on a polar coordinate plane as opposed to a rectangular coordinate plane. And the coordinates are going to be written as r, theta. And what does that r stand for? It stands for the distance from the origin, or you can think about it as the radius of a circle. And the theta is the angle measured from the positive x-axis counterclockwise. And of course, counterclockwise is going like this. And that's how we always do our angles in terms of positives. So let's do some examples. Let's make this a little bit more concrete. Well, first of all, this is a radius of 1. This will be a radius of 2, a radius of 3, and a radius of 4. Okay, that was bad. But you get what I mean. So if I want to plot 3, 150, that means I'm going to be 3 units away from the origin, or you can think of it as a radius of 3, and I'm going to be at 150 degrees. So here's my 150 degrees. I'm going to go out 3 radiuses. So this would be 1, this would be 2, and this would be 3. So my answer would be right there. So I'm basically out 3 units, okay, and I went to 150 degrees. All right, where would 4, 300 be? Well, 300 is right here, and going out all the way to 4 would be 1, 2, 3, 4. It would be all the way out here. Okay, so that would be my coordinate, and I probably should have labeled this as A and this as B. Okay, next one is going to be 1, 240. So find my 240, and I'm going to go out 1 radius away from the center, and that's going to be my C. Not too bad, right? All right, now we can also do graphing polar coordinates when you look at radians. And so, I mean, don't panic. We've got pi over 6, which is the same thing as 30 degrees, pi over 3, which is 60 degrees, 90 degrees. So same thing, it's just we're writing it with different units. All right, point D would be a radius of 2 and at 2 pi over 3. So that would be right here. Okay, next one is 3, 7 pi over 6. So that would be here. And F is 1, pi. So we're going to be out towards pi, but I'm going to choose 1 radius away from that center, or 1 unit away, and that's my F. So you might be saying, whoa, this is wicked easy, and you're totally right, but it can get 1 level harder, and it's not much harder, but notice how we can have negative radius and a negative degree. Forgot my degree symbol here. So first of all, let's start off with point G, which is 260. So that's going to be this right here. That's going to be G. Now, how do we do a radius of -2? Well, basically, you think about it as being the same thing as this, except you go in the opposite direction of the negative of the 2. So for example, for positive 260, I went up 2. But actually for negative 260, you would still be on that 60 line, but you would go backwards 2. Oops, sorry about that. So that would end up being, on this 240, 1, 2. So we'd go in the opposite direction than the positive 2, and we would end up right there. And if you have a hard time, and I kind of do, seeing where that straight line goes, you could have just done 60 degrees plus 180, and you would have seen that it was on the 240 right here. So that's where that point is going to be. It's basically the same point, but when it's a negative radius, you go in the other direction. So this is going to be point H. All right, let's try -3, 120. Well, where's my 120? It's right here. Okay, And if I want to graph the positive point, I would actually be right about here, right? But since this is a -3, we're actually going to go in the opposite direction. So we're going to go, it was 3 here, and it's going to be a 1, a 2, and a 3 in that other direction. And our point is going to be right here. And again, if you have a hard time like figuring out where that is exactly, you could have just done 120 plus 180 degrees to figure out it was on that 300 degrees. Okay, so that's my point I. All right, now, we've talked about negative radiuses, but we've not talked about a negative angle, and this one's significantly easier. What I want you to think of is when we're dealing with negative angles go below the x-axis in a clockwise manner. So for example, if I'm going in this direction, that would be something like a negative, let's say this was -60 degrees. But interestingly enough, how else could we write -60 degrees? Right, we could also write it as 300 degrees, right? Because 300 plus that 60 give you 360. All right, so keeping that in mind, there's a couple ways to do it. You could convert this angle, if you wanted, into a positive one, but I don't like that way. I like to go down. So what I mean by that is I know that I'm going to be kind of starting here, but I'm actually going to go down 60 degrees. So this is down 30 degrees and then down another 30 degrees. So clearly -60 would be on this line right here, right? That makes sense that that's 300 degrees right here, that this would be a -60 degrees. And then we also know that we've got a radius of 3. So I'm going to be on this angle right here, but I'm going to be a radius of 3. And that radius of 3 is 1, 2, 3. And we're actually going to be at the same exact spot as I. Okay, so I can write that this is the point I / the point J. So the takeaways for the negatives for the radius are plotted pretty much the same exact way, except just go in the opposite direction. But when you have a negative angle, just treat that as the angle going down the opposite direction. Okay, that's it for that unit. Not too bad. Now we're going to move on to converting from polar to rectangle in our next video. Can't wait to teach you that.